On March 27, 2026, three of Japan's technology giants, ROHM, Toshiba, and Mitsubishi Electric, signed a memorandum of understanding to integrate their power semiconductor operations. This is not a mere tactical partnership. It is a strategic survival mechanism. By unifying, these firms aim to achieve the scale and technological depth required to compete against entrenched European incumbents and state-subsidized Chinese competitors. This consolidation marks a historic turning point for the Japanese electronics industry in its quest to define the next generation of power electronics. The primary objective of this consolidation engine is to create a unified national champion that ranks as the second-largest power semiconductor manufacturer globally, trailing only Germany's Infineon. By combining their assets, the entity will command a 9.7% to 10.9% global market share. This scale is essential for the transition to 200 mm wafer manufacturing, providing the flow capacity and structural realignment necessary for global survival in an increasingly competitive landscape. Three powerful external forces have mandated this move. First, geopolitical tech sovereignty treats semiconductors as critical national infrastructure, backed by the EU CHIPS Act and Japanese subsidies. Second, the Chinese subsidy multiplier allows competitors to offer products 30 to 35% cheaper than Western equivalents. Third, end-market demand rotation shows a shift from stabilizing EV growth toward the explosive energy requirements of AI data centers, where power consumption is doubling every 6 months. This alliance is built on zero redundancy, combining complementary strengths without overlapping waste. Mitsubishi Electric brings dominance in high-voltage rail and industrial infrastructure. Toshiba contributes a deep customer base in low to medium voltage discrete components for consumer electronics. ROHM provides world-class silicon carbide SiC materials and automotive innovation. Together, they form a full-spectrum power management portfolio capable of serving the entire modern digital economy. The industry is facing a capex cliff as it transitions from 150 mm to 200 mm wafers. While larger wafers structurally lower unit costs, the upfront fabrication tool costs are too severe for any single Japanese manufacturer to absorb independently. This alliance pools R&D resources and consolidates plant footprints, providing the exact economy of scale required to bridge this gap and maintain long-term cost competitiveness. History provides a grim warning for those attempting to scale 200 mm capacity individually. Pioneer Wolfspeed filed for Chapter 11 bankruptcy in mid-2025 due to massive capital burn and scaling delays. This caused a ripple effect for Renesas Electronics, which was forced to abandon its SiC plans and record a massive 236.6 billion yen write-off in 2025. This Renesas lesson highlights that a joint alliance is the only viable path for latecomers to secure a foothold. Winning requires mastery of next-generation materials. Silicon Carbide, SiC, is the heavyweight workhorse, mandatory for high-voltage EV powertrains due to its unmatched thermal conductivity. Gallium Nitride, GaN, offers extreme electron velocity and high-frequency speed, making it mandatory for ultra-efficient AI server power supplies. The alliance leverages ROHM's SiC expertise and Toshiba's emerging GaN topologies to dominate both fronts. Market demand is bifurcating. The automotive path is moving toward 800 volts EV systems, dictating a structural shift from silicon to SiC. Simultaneously, AI data centers are experiencing hypergrowth, demanding high-frequency GaN to minimize energy loss during massive power distribution. The combined wide bandgap SiC GaN market is projected to reach $16 billion by 2034, and this alliance is positioned to capture that growth. Our competitors are not standing still. Infineon remains the undisputed number one, with an 18.5% share and massive 200 mm expansion in Malaysia. ST Microelectronics is pursuing aggressive vertical integration with its Catania SiC campus and Chinese joint ventures. onsemi is dominating the high-growth AI sector with its fab-right optimization. Japan's unified front is a necessary response to these scale-driven global strategies. China has evolved into a major global challenger through a subsidy cascade. Under their 2026 to 2035-year plan, 7% plus annual R&D growth is mandated. Chinese firms like SICC are flooding the market with 200 mm SiC substrates, causing a global price crash. This state-driven vertical integration results in battery packs and power electronics priced 30 to 35% lower than Western equivalents, deeply distorting standard market economics. A critical, complicating factor is Denso's 1.3 trillion yen bid to acquire ROHM. This presents two paths. Path A is a vertical captive model, where ROHM joins the Toyota Denso ecosystem, gaining financial backing but losing independent supplier status. Path B is the horizontal alliance model we are discussing today, which creates a global merchant supplier capable of serving all automakers and AI infrastructure giants independently. The ultimate value proposition is a full-spectrum architecture. No single company could engineer this entire pathway alone. By combining Mitsubishi's 20K VAC grid dominance, ROHM's 800 volts DC automotive modules, and Toshiba's 1 volt DC fast-switching AI topologies, the alliance captures value at every single voltage step of the modern digital economy. This is the definitive framework for reclaiming foundational leadership. The future strategy rests on 4 pillars. 1. Accelerating 200mm SiC GaN lines for global cost parity. 2. Dominating AI infrastructure with modules engineered strictly for GPU energy conversion. 3. Geographic diversification into India and Southeast Asia to bypass geopolitical choke points. 4. Integrating digital signal processing and sensors directly into intelligent power modules to move up the value chain. Success is not guaranteed. External risks include escalating trade barriers, which could impact $30 billion in equipment spending and stall the 200mm roadmap. Internally, the Renesas lesson warns of management paralysis and slow, consensus-heavy decision-making. To survive, the new entity demands a ruthlessly autonomous leadership structure, completely insulated from parent corporate bureaucracy. The prize is clear: a global power semiconductor market reaching $58.8 billion in 2026. In an era where soaring AI demand clashes with fragile, restricted supply chains, structural scale is the only answer. This merger is Japan's definitive blueprint to reclaim leadership in the 21st century digital industrial economy. Our success will define the foundational technology of the next generation.